Hello guys, welcome back to this video. And in this video, we are going to solve today's Leetcode Daily challenge. Let's open it. Leetcode Daily challenge. Leetcode. Hmm. Okay. So today's problem name is minimum add to make parenthesis valid. So let's try to read a problem statement. This is a medium problem. Uh, so the problem states that a parenthesis string is valid if and only if it is empty string. It can be written as AB where A concatenated with B where A and B are valid strings, or it can be written as A. Okay, you are given a parenthesis string as in one move you can insert a parenthesis at any position. For example, this. Okay, for this example, return the minimum number of moves you have to make S value, right? So let's see the test cases first. So for the first test case, it is so the for let's copy it and move it to the Excel. Okay. Now, if you look at the example one, so what you can observe is so the given input is s equals to no, not closing braces. I have to remove this. So opening braces, closing braces, and closing braces. And the answer for this test case is 1. Output is 1. Why? So the idea is you can add one parenthesis at the beginning and you can make this as a valid parenthesis, or you have one more option. Instead of adding at an index 0, what you can do, you can also add just before the last parenthesis, and you can make it a valid parenthesis. So by doing this, you can just observe that for every parenthesis, for every opening parenthesis, there must be a closing parenthesis. Similarly, for any of the closing parentheses, you must add some opening parenthesis. And we don't need, for this particular problem, we don't need to find out the ways to do that. We just need to find out what are the number of parentheses that we can add to make it valid, right? So you can add at any position. You just have to make it valid. Similarly, for the example number 2, the second input, we have three opening parentheses. What we can do is we can add three more closing parentheses. Or we have also one more option, like we can do like this also, right? So in both cases, this is valid only. And I think more ways are possible, like one add here and also add here. So this is little bit nested type. Uh, so everything is valid as long as it is a valid parenthesis. It works. You just have to tell what is the minimum number of the parentheses that needed. So whenever we have to balance some parentheses related things, the very straightforward idea that strikes our mind is using stack. So what we can do, we can use stack. So let's say for this example, S is like this and this. Okay. So we just need to ignore the parentheses which are already balanced. So what we will do, we will just add whenever we see opening parenthesis, we will push it into this tag, right? And whenever whenever we will see there is some closing braces, we will just check our stack top. If it is opening, means it will match with the closing parenthesis, and we will pop that element from the stack. And if stack is empty, and we will we found some closing parenthesis, then we will add it into the stack. So for this test case, for this given test case, the at zeroth index, this is opening parenthesis, we will add it here. For the second index, like first index, it again is opening parenthesis, so we will add it. Now for the index number 2, this is a closing parenthesis. So in the case of closing parenthesis, we will check what is the top of the stack. In the top of stack, it is closing opening parenthesis. We will pop out this. Means we will erase it from here. Now, now we will move to the index number 3, right? So uh, for the index number 3, what we will do, we will just insert it, right? Now, strings over. Now, the final answer, whatever the elements that are present in this stack, will be the final answer, because that are the characters, that are the parentheses which are not balanced, because they are remain unbalanced. So that's why the element which are in the stack is the answer. Means we just have to return the stack size, stack dot size, right? So the okay. So here, the time complexity will be order of n, because we are iterating over the complete string. So that's why the time complexity will be order of n. And if you talk about space complexity, the space complexity is order of 1, not 1, n. Why? Because we are using stack, and at the worst case, it may be possible that in the worst case, the size of stack is also order of n, right? If every parenthesis is opening parenthesis, in that case, uh, the space complexity will be order of n, right? Now, uh, if you look it carefully, then you will observe that, like, what we are doing in this problem, we are just matching the parenthesis. For solving this particular problem, we are just matching the parenthesis, right? So can't we do with some variable, just using some variable instead of using stack to keep track of the whether the whether the stack, there is some element in stack, we have to check the stack top. We can do simulate the same process using variable also. How? Let me tell you how. So just I will take the same example here. So as will be like this. What is the example? As will be like opening, closing, opening, closing, open. Not not opening. Let me remove it, and it's a closing, right? It's opening here. So what we will do, we will keep track of two variables. One is open. Initially it will be 0, and one is second one is close. It will be also 0 initially. Okay. Now whenever you see there is some opening bracket, you have to just iterate over this string. So this the character which is at the index number 0, it is opening bracket. So what we will do, we will increment here. Let me write it again. We will increment our opening to 1. Now again at index number 1, again it is opening. So I will increment our opening to 2. Now it's a closing. So in the case of closing, we have two cases. in the case of closing, opening open equals to 0 or open is greater than 0. So when open is greater than 0, it means there is some open bracket that that came previously before that particular index. So in that case, what we will do, we will match our closing bracket with that particular opening bracket. It means for this index, we will decrement our open. Means we are decrementing our open because there is some closing bracket which we can match with some previous opening bracket. But when there is no opening bracket at all, then in that case we will increment closing braces. So this is the idea. So for the closing, the two cases are open greater than 0 and open equal to 0. When open, in this case, open minus minus, in this case, open. In this case, let me remove it. In this case, close plus plus. And at the end, we will just return open plus close. Right? Because what these are the number of the parentheses which remains unbalanced. So this is the overall idea of this problem. In this particular approach, what we are doing is just improving over the space complexity. So in this case, the complexity will be still order of n, but space complexity improved to order of 1, right? So this is the overall idea for the problem. So let's try to code it, and let's try to code it. So okay, so as discussed, we'll initialize two variable open close into open, right? Now for auto and x, what I will do, so better is to don't use auto, use char because this is more readable. And here instead of x, ch is more readable. So now I will check if ch equals to opening bracket. What I will do? Open plus plus. Now else if ch equals to closing bracket and open is greater than 0. In this case, we found some closing bracket which we can match with some opening bracket. So that's why we will just decrement the count of open. Otherwise, there is no opening bracket available, and we found some closing braces. So in that case, what we will do in that case, we will just increment our closing bracket. Now, at the end of this function, we will return open plus close, which will be the final answer for this particular problem. Let's try to run it. So yeah, for sample, it got accepted. Let's try to submit it. So again, accepted. So here we beat we beat 100% of the solution. So let's try to discuss the complexity. Complexity we already discussed. So the complexity will be order of n only because we are iterating over the complete string, whole string. So thank you so much. Thank you so much for watching this video and see you in the next tutorial. Thank you. Next video. Bye bye.